Welcome back to the Vision Campus. Today let's talk about the benefits of using cameras in medicine. Before imaging technology became available in medicine, it was often difficult to generate accurate diagnostic information. In the year 1800, for example, procedures called exploratory surgery were very common. This forced doctors to use invasive procedures like surgery to make a cancer diagnosis. Today, with the help of imaging and vision technology, there are many camera-based diagnostic devices on the market. There are fundus cameras to check the back of a patient's eye, automated microscopy for the analysis of body fluids such as blood or urine, intraoral scanners that help eliminate the uncomfortable wax stamp that nobody really likes, digital dermoscopes for identification and tracking of suspicious skin regions, and many, many more. All these devices give information that can contribute to both the diagnosis process and the intervention that follows. There are 4 major benefits cameras can bring to the medical domain. Number 1. Documentation. With a digital image, the clinician can examine the region of interest more easily than by looking through an optic attached to a device. Also, the clinician can add annotations to the image data so that suspicious regions can be re-identified and tracked over time. Digital patient records can store all these images and information so that they are available for clinicians worldwide. Number 2. Image analysis. In today's tumor diagnostics, sampling and analyzing tissue slides under the microscope is still common practice. With automated microscopes, the image of the slide can be scanned. Modern image analysis algorithms, such as neural networks, can then search the image for suspicious regions to propose an analysis to the pathologist. This can be done in minutes, while the manual investigation takes several hours and relies on a single human operator. Number 3. Automation. There are 2 trends driving development in this field. The need for multiple diagnostic procedures is increasing. This is also due to demographic factors. At the same time, rising labor costs create the need for more automation. Tubes of blood samples, for example, no longer need to be manually stored by laboratory workers, but are archived using barcode reading classification systems. Number 4. Visualization. Cameras also serve as the eye in many sophisticated imaging techniques. Used as endoscopes, or so-called smart pills, millimeter-sized cameras record the device's path through the inner parts of our body. Fluorescence-guided surgery lets the surgeon distinguish between healthy and cancerous tissue in real time during the procedure. Fluorescence angiography lets the ophthalmologist see if the tiny vessels in the background of the eye are properly connected. Hyperspectral cameras can distinguish between tissue that is flushed with blood and tissue suffering from too little oxygen. Cameras designed for use in medicine and life sciences also face some tough performance and form factor requirements. Because the diagnostic process often depends directly on the camera's image, the criteria that make an industrial camera suitable for diagnostic tasks include reliability and robustness, a high color fidelity, a long-term availability, and the right feature set. The cameras must be manufactured with very high precision to ensure consistent performance. Taking an image of the same region of interest must result in comparable images over time. Unlike consumer cameras, industrial cameras must provide a long service life and be extremely reliable. They also need to be produced under certain industry-adopted ISO standards to fulfill the requirements of medical device manufacturers. Since in many cases a diagnosis is directly based on color information, the camera must be highly accurate and project in real-world colors into the digital image. In other words, the color that the clinician sees on the monitor must be the same color that is present in the diagnostic region of interest in the real world. The certification process for many diagnostic devices is very exhaustive and time-consuming. Therefore, the cameras for such devices must be available on the market for a long time. Unlike manufacturers for quickly changing consumer cameras or sensors, industrial camera manufacturers must offer their product for a very long time span to serve this need. Generating just the raw sensor data is typically not sufficient for manufacturers of camera-based diagnostic devices. The right camera features, such as color interpolation, color calibration, sharpening corrections, and advanced color features often make the difference when choosing a camera supplier. This was just a short glimpse into the contribution of cameras to the medical field. Thanks to reduced costs and smaller sizes, more and more medical devices will be equipped with machine vision in the future. We will encounter these advanced devices more frequently in medical settings of all kinds. Their increasing affordability will see them becoming more common in economies and locations around the world. Thanks for watching.